Let's evaluate. Does this really apply to all cases? Now consider this analogy. Let's use a rocket as an example of a working mechanical system. Now, make some parts independent. Imagine the rocket has two fuel tanks. If they are dependent to one another, when one fails during the flight, both tanks can't deliver fuel to the rocket and it crashes. On the other hand, what if the fuel tanks were independent, and one tank fails during the flight? The second engine is not affected and the rocket can still operate with one tank. Let's consider the engine now. If the system tells the engine to reserve fuel, and the independent engine decides to continue at full fuel consumption, the fuel will run out and the rocket crashes. However, what if the engine considered the system? The system has already set a guideline of fuel consumption. If the engine uses fuel at its own rate but doesn't exceed the guideline, there is sufficient fuel for the whole journey. Through the examples, we believe that firstly, independence is good as it reduces failures due to dependency. However, independence can also lead to failure through decisions made with incomplete information. Therefore, a certain degree of opinion from others can help independent bodies work effectively without governing their work completely. Finally, our definition of independence is when something can work without regulations while staying within guidelines. External opinions can be offered but it has no significant influence to the decision-making body.
Created using Powtoon.